NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math video. Today we're going to solve a fractional equation step by step, following a specific algorithm. Let's get started. Here's our problem. We need to solve the equation 3 over 3 minus x plus 4 over 3 plus x equals 8x plus 3 over 9 minus x squared. Step 1. We'll start by moving all terms to the left side of the equation to get an expression equal to 0. Step 2. We need to find a common denominator for all fractions. First, let's note that 9 minus x squared can be factored as the product of 3 minus x and 3 plus x. Step 3. Let's expand the numerator to get a clearer expression. Step 4. Now let's expand using the distributive property. Step 5. Let's combine like terms to simplify our equation. Step 6. Now we'll isolate x by dividing both sides by -9. Let's verify our solution by checking if x equals 2 satisfies our original equation. We would substitute x equals 9. Let's verify our solution by checking if x equals 2 satisfies our original equation. We would substitute x equals 2 into each fraction and confirm the equality. I'll leave this verification as an exercise, but you'll find that the solution x equals 2 is correct. In summary, we've solved the fractional equation by following these steps. First, we moved all terms to one side to get 0 on the right. Then, we found a common denominator by factoring the denominator of the right-hand term. We expanded and simplified the numerator combined like terms, and finally solved for x. The answer is x equals 2. Thanks for watching. X equals 2. Thanks for watching. Let's look at our example. Let's begin solving this problem. In step 1, we'll use cross multiplication to eliminate the fractions. We'll multiply both sides of the equation to get a cleaner form. In step 2, we'll distribute the numbers to expand both sides of the equation. In step 3, let's multiply both sides of the equation by x to eliminate the fractions. This will give us terms with x squared. Now for step 4, we'll gather all the terms with x squared on one side and all constant terms on the other side. In step 5, we'll divide both sides by 2 to solve for x squared. For step 6, we'll take the square root of both sides to solve for x. Our final answer is x equals plus or minus 2. Let's start with our equation. We have the fraction 2x minus 7 over 9 minus the fraction x minus 5 over 6 equals the fraction x minus 9 over 8. Step 1. We'll move all terms to the left side of the equation. This means we'll subtract the fraction x minus 9 over 8 from both sides. When we move it to the left side, it becomes negative x minus 9 over 8. Step 2. We need to find a common denominator for all the fractions. The least common multiple of 9, 6, and 8 is 72. So, we'll convert all fractions to have a denominator of 72. Step 3. Now, let's expand the expression in the numerator. For the first term, we multiply 8 by 2x minus 7, which gives 16x minus 56. For the second term, we multiply 12 by x minus 5, which gives 12x minus 60. And for the third term, we multiply 9 by x minus 9, which gives 9x minus 81. Step 4. We'll combine like terms in the numerator. 16x minus 12x minus 9x equals negative 5x. And negative 56 plus 60 plus 81 equals 85. So our equation becomes negative 5x plus 85 over 72 equals 0. Step 5. Since we want to isolate x, we'll multiply both sides of the equation by 72 to eliminate the denominator. This gives us negative 5x plus 85 equals 0. Step 6. Now we'll solve for x. We subtract 85 from both sides to get negative 5x equals negative 85. Step 7. Finally, we divide both sides by negative 5 to isolate x. Negative 85 divided by negative 5 equals 17. Therefore, x equals 17. Let's verify our solution by substituting x equals 17 back into the original equation. Let's check the left side first. For the first fraction, 2 times 17 minus 7 over 9, we get 2 times 17, which is 34, minus 7, which is 27, all over 9, which equals 3. For the second fraction, 17 minus 5 over 6, we get 12 over 6, which equals 2. And for the right side, 17 minus 9 over 8, we get 8 over 8, which equals 1. So, the left side becomes 3 minus 2, which equals 1. and the right side is also 1. Since both sides are equal, our answer x equals 17 is correct. To summarize, we solved this fraction equation by, first, moving all terms to the left side. Second, finding a common denominator, which was 72. Third, expanding the numerator expressions. Fourth, combining like terms to get negative 5x plus 85 over 72 equals 0. Fifth, multiplying by 72 to get negative 5x plus 85 equals 0. Sixth, isolating x by subtracting 85 from both sides. And finally, dividing by negative 5 to get x equals 17. Here's our problem. We need to solve the following equation. X plus 1 over 2x minus 3 minus x squared plus 7 over 4x squared minus 9 equals 2 over 2x plus 3 minus x minus 1 over 6 minus 4x. Let's start solving this equation step by step. The first step is to rearrange all terms to one side of the equation to make it equal to 0. So we'll move all terms to the left side of the equation. We get x plus 1 over 2x minus 3 minus x squared plus 7 over 4x squared minus 9 minus 2 over 2x plus 3 plus x minus 1 over 6 minus 4x equals 0. For the next step, let's recognize that 4x squared minus 9 can be factored as 2x minus 3 times 2x plus 3. Also, we can rewrite 6 minus 4x as minus 2 times 2x minus 3. So our equation becomes x plus 1 over 2x minus 3 minus x squared plus 7 over 2x minus 3 times 2x plus 3 minus 2 over 2x plus 3 plus x minus 1 over negative 2 times 2x minus 3 equals 0. Now, we need to find a common denominator for all these fractions. Looking at the denominators, we see 2x minus 3 times 2x plus 3, 2x plus 3, and negative 2 times 2x minus 3. The least common denominator would be 2 times 2x minus 3 times 2x plus 3. So we'll convert all fractions to have this common denominator. Now, let's combine all terms over the common denominator. This gives us 2 times 2x plus 3 times x plus 1 minus 2 times x squared plus 7 minus 2 times 2x minus 3 times 2 plus 2x plus 3 times x minus 1 all over 2 times 2x minus 3 times 2x plus 3 equals 0. Since the denominator is not 0, the equation is true when the numerator equals 0. So let's focus on the numerator. 2 times 2x plus 3 times x plus 1 minus 2 times x squared plus 7 minus 2 times 2x minus 3 times 2 minus 2x plus 3 times x minus 1 equals 0. Let's expand the products in our numerator. For the first term, 2 times 2x plus 3 times x plus 1 equals 2 times 2x squared plus 2x plus 3x plus 3, which simplifies to 2 times 2x squared plus 5x plus 3. For the remaining terms, let's continue expanding. The second term is negative 2 times x squared plus 7, which equals negative 2x squared minus 14. The third term is negative 2 times 2x minus 3 times 2, which equals negative 2 times 4x minus 6, which simplifies to negative 8x plus 12. The fourth term is negative 2x plus 3 times x minus 1, which equals negative 2x squared minus 2x plus 3x minus 3, which simplifies to negative 2x squared plus negative x plus 3. Now we can combine all these expanded terms. We have 2 times 2x squared plus 5x plus 3 plus negative 2x squared minus 14 plus negative 8x plus 12 plus negative 2x squared minus x plus 3. Combining like terms for x squared, 2 times 2x squared plus negative 2x squared plus negative 2x squared, which equals 4x squared minus 2x squared, which equals 0. Combining like terms for x, 2 times 5x plus negative 8x plus negative x, which equals 10x minus 8x minus x, which equals x. Combining constants, 2 times 3 plus negative 14 plus 12 plus 3, which equals 6 minus 14 plus 12 plus 3, which equals 7. So our equation simplifies to x plus 7 equals 0. So our equation has simplified to x plus 7 equals 0. Solving for x, we get x equals negative 7. Therefore, the solution to our equation is x equals negative 7. Great job! We've successfully solved this complex rational equation. Let's summarize what we've learned in solving this rational equation. We first rearranged all terms to one side of the equation. Then we factored the denominators to help find a common denominator. We combined all terms over this common denominator. Next, we set the numerator equal to 0 and expanded all the products. Finally, we combined like terms and solved for x, finding that x equals -7. This method can be applied to many complex rational equations. Remember to always check your answer by substituting back into the original equation. Example, our first equation is 3 over x plus 5 plus 2 over x squared minus 25 equals 3 over 5 minus x. We'll follow the exact algorithm. Step 1. Factor the denominator x squared minus 25 using the difference of squares identity. Step 2. Rewrite the right side so its denominator matches x minus 5. Since 5 minus x equals negative of x minus 5, 3 over 5 minus x becomes -3 over x minus 5. Step 3. Bring every term to the left side, setting the equation to 0. Step 4. Combine the three fractions over the common denominator x minus 5 times x plus 5. Step 5. A fraction equals 0 only if its numerator equals 0. Step 6. Expand and simplify the numerator. 3x minus 15 plus 2 plus 3x plus 15 equals 0, which simplifies to 6x plus 2 equals 0. Simplify the numerator. 3x minus 15 plus 2 plus 3x plus 15 equals 0, which simplifies to 6x plus 2 equals 0. Step 7. Solve for x. 6x equals -2, so x equals -1/3. Check the domain x cannot be plus or minus 5. -1/3 is allowed. Example. Now solve x plus 2 over x plus 1, plus 2 minus x over 1 minus x, plus 4 over x minus 1, equals 0. Step 1. Express every term with the common denominator x plus 1 times x minus 1. Note that 1 minus x equals negative of x minus 1, so the second fraction becomes negative of 2 minus x over x minus 1. Step 2. Regroup the last two terms by factoring x plus 1. That yields left parenthesis x plus 2, right parenthesis times left parenthesis x minus 1 right parenthesis plus left parenthesis x minus 1 right parenthesis plus left parenthesis x plus 1 right parenthesis times x minus 2 plus 4. Step 3. Simplify x minus 2 plus 4 to x plus 2. Now, both terms contain x plus 2 as a factor. Step 4. Factor out x plus 2. The remaining factor is x plus 1 plus x minus 1, which is 2x. Step 5. Apply the zero product property. Either 2x equals 0, which gives x equals 0, or x plus 2 equals 0, which gives x equals -2. Remember the domain excludes x equals plus or minus 1 from the original denominator. Problem statement. Solve the equation open parenthesis t minus 1 close parenthesis over t plus 4 minus 2 over t minus 4 equals 7 over 6. Step 1. Move all terms to one side to set the equation equal to 0. Step 2. Multiply by the common denominator 6 times t plus 4 times t minus 4 and combine to a single fraction. Step 3. Expand the products in the numerator. Step 4. Distribute and collect the terms. Step 5. Combine like terms for t squared, t, and constants. Step 6. Multiply the equation by -1 to make the leading coefficient positive. Step 7. Multiply the equation by -1 to make the leading coefficient positive. Step 7. Factor the quadratic expression. Step 8. Use the zero product property and solve for t. Second example. Problem statement. Solve 3 over 2x equals x plus 2 over x squared minus 3x. Step 1. Move all terms to one side to set the equation to 0. Step 2. Use the common denominator 2x times x minus 3 to combine the fractions. Step 3. Expand the numerator and simplify. Step 4. Combine like terms to get a simple linear equation. Step 5. Solve the linear equation for x. Quick summary. We set each equation to 0, used a common denominator to combine fractions, expanded. Example. We will solve the equation 5 over x minus 4 over x times x minus 2 equals x minus 4 over x minus 2. First, move all terms to the left side to set the equation equal to 0. Next, identify the least common denominator x times x minus 2. Combine the fractions over that denominator. Since a fraction equals 0, when the numerator is 0 and the denominator is non-zero, we set the numerator equal to 0 and remember the domain restrictions. Now expand the numerator. 5 times x minus 10 minus 4 minus x squared plus 4x. Then combine like terms. Multiply both sides by -1 to get a positive leading coefficient. Factor the quadratic. Use the zero product property to find candidate solutions. Finally, apply the domain restrictions. X cannot be 0 and x cannot be 2, so we remove any invalid value. Second example. Solve the equation open parenthesis 2x plus 3 close parenthesis over 2x minus 2 minus 5 over x squared minus 1 equals 2x minus 3 over 2x plus 2. First, factor all denominators. The common denominator is 2 times x minus 1 times x plus 1. Write every term with this common denominator and move everything to one side. Expand the numerator carefully. Combine like terms to get a linear equation. Then solve and check domain restrictions. Example. First equation. Open parenthesis 3x minus 2 close parenthesis over x plus open parenthesis 2x plus 5 close parenthesis over x plus 3 equals 5. Step 1. Move all terms to the left and set the equation equal to 0. Step 2. Combine the terms over the common denominator x times x plus 3. Step 3. Expand only the numerator. Step 4. Combine like terms in the numerator. Step 5. Simplify the polynomial. Step 6. Add 6 to both sides, or equivalently move the constant to the right. Step 7. Divide by -3, so x equals -2. This does not zero any denominator, so it is valid. Example. Second equation. 1 over x plus 1 minus 1 over x equals 1 over x minus 1 minus 1 over x minus 2. Step 1. Move every term. Second equation. 1 over x plus 1 minus 1 over x equals 1 over x minus 1 minus 1 over x minus 2. Step 1. Move every term to the left, so the right side is 0. Step 2. Combine the fractions over the common denominator x times x minus 1 times x plus 1 times x minus 2. Step 3. Factor inner products to highlight common trinomials, exactly as written. Step 4. Expand each group product. Step 5. Combine into a single long sum before simplifying. Step 6. Cancel and combine like terms to reach a linear equation. Step 7. Move the constant and isolate the variable. Step 8. Divide both sides by 4. So x equals 1/2. This value keeps all denominators non-zero, so it is valid. Recap. We followed the provided solution structure precisely. Divide both sides by 4. So x equals 1/2. This value keeps all denominators non-zero, so it is valid. The equation is x plus 1 over x minus 1 minus x minus 1 over x plus 1 equals 3x times the quantity 1 minus x minus 1 over x plus 1. We first note the domain. X cannot be 1 and x cannot be -1. Next, distribute the 3x on the right. Now, bring everything to the left side. To remove denominators, multiply both sides by the common denominator x squared minus 1. Simplify and combine like terms. Factor to solve. Finally, check the solutions against the domain. Now, the second example. We will again start with the problem, list the domain, clear denominators, simplify, and finally check whether any obtained solution is valid. The equation is 2x plus 3 over x minus 1 minus 2x minus 3 over x plus 1 equals 10 over x squared minus 1. Domain restriction. X cannot be 1 and x cannot be -1. Multiply both sides by x squared minus 1. Now expand and combine like terms. Solve the resulting linear equation. Finally, check against the domain to avoid extraneous solutions. Quick recap. When solving rational equations, first write the domain from the denominators. Then clear denominators by multiplying by the common denominator. Simplify to a polynomial equation. Solve. And finally discard any answers that violate the domain. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.